Okay, so hi everyone. My name is Mohammad Asim, and my topic is creation and implementation of BIM model measurement rules. And my supervisor is Miguel Angelo da Sardinia, and the co-supervisor is Jos Granger. And I did the dissertation with an associated partner of BIM Plus, that is Top Informatica, which is a Portuguese company, a partner and reseller of CPA software application within the Portugal and other Portuguese-speaking countries. The main aim of the dissertation was to develop the general measurement rules for BIM models using CPA Open BIM quantities application. And why we have developed the general measurement rules to extract the model quantities and generate the final VOQ of the project. Before developing these measurement rules, it is essential to accomplish the following objectives for Q2 and cost estimation purpose. Like, first is the formulation of WBS structure to streamline and standardize the process, and then establishing the general modeling rules to create a precise 3D model following the level of information need, and using OpenBIM file format to facilitate interoperability between the software. So WBS is a systematic and hierarchical technique for organizing and categorizing uh, the many components and activities of a building project. Basically, there are two types of WBS: phase-based WBS and deliverable-based WBS. So, deliverable WBS is a hierarchical breakdown of a project, emphasizing its deliverables. Start with the final deliverables at the top level and break down into smaller deliverables and sub-deliverables. A phase-based WBS is a WBS, sometimes called the process-based WBS or activity-based WBS, arranges the project into distinct phases or stages of work, begins with the project phases at the top level, and breaking it down into tasks and subtasks within each phase. And from the cost estimation point of view, the deliverable-based WBS will be recommended as it clearly defines the deliverables and focuses on finished items. If now we will talk about the level of information need, what is the level of information need and why it is required to extract the model quantities and to generate the final model. The level of information need is an essential factor in effectively sharing the information model in BIM settings. It is a framework that groups the requirement related to geometry, information, and documentation in BIM project. Like for an object, to develop an object, what we need to have, we need to know the geometrical information of that object, and we need to know the alphanumerical information. For knowing the geometrical information, what should be in the geometrical information? The detail, dimensionality, location, appearance, and parametric behavior of that element. And in case of alphanumerical information, like what is the metadata contained that particular element and how that element will be identified. And after defining the level of information need, now we will talk about the BIM model measurement rules methodology. How we will achieve the final measurement rules methodology. There are steps involved in this work, like for the quantitative of a QTO purpose. Like first, we have to formulate the WBS codes and for each and every element present in the model, and after that we have to produce a 3D model following the established level of information need and created modeling rules. After creating the 3D model, we have to extract it in an IFC format, considering the IFC export configuration. Now we will be having an IFC model containing the all the information required for its Q2 and cost estimation purpose. But for the next process, we have to develop the cost database. To link the cost database with the IFC model, what we have to do is we have to integrate the cost data with the IFC model with the help of established measurement rules, and those measurement rules will automatically generate the final VOQ of the project. So how we will do it? We will further evaluate it step by step. Like first, formulation of WBS code. Like for this study purpose, we have chosen the price generator or generator of the pressure by CPA for this study purpose, in which this WBS contains all the elements required to compose a project. The element contains their specific codes and their per unit prices. Uh, based on the labor, equipment, and materials required to perform per unit of the quantity of that particular element. But sometimes what happens, these codes like remains unaltered when the character, if we modify the characters of that component. So it creates a small issue. Like we cannot segregate the element by the similar codes. So to resolve this issue, what we have to do is we have to add an additional identifier into the standard code. Like we are having a standard for a slab, but if there are the slab is there are two types of slabs in the project. Like one is 30 centimeter thick and another is 20 centimeter thick. So we have to segregate both the slabs, and for segregating them, we have to use the additional identifier for segregating it for the material purpose or for the from the thickness point of view or from the location point of view. So accordingly, we have to set all the WBS code required to perform a 3D model. And the next step will be defining the level of information need and the modeling rules for the structural model elements. And then I will define about the architectural model elements as well. So the level of information need for structural model elements is defined considering the design stage of the project. Like we have limited our scope to the design stage of the project, in which when we will talk about the modeling rules for the structural model element, we have considered the CSRMC guideline, that is for the rules of measurement for modeling the structural model. In that case, according to the CSRMC guidelines, what it says, the column should be modeled between the slab top to next level slab top. And if we talk about the level of information need, we have to understand what is the purpose of that is level of information need. The purpose is related to its quantity takeoff. So accordingly, its alphanumerical and geometrical information will be according to that. Like in case of alphanumerical information, the information content will be according to its quantity sets. Like property set is the quantity set of the object, like QTO column based quantities. And what is the object? Object is column, and the layer is the code layer. And what is the IFC category? The IFC category is IFC column. And if we will talk about the IFC suggested Q2 property, what will be the Q2 property suggested by the IFC? That will be, like in case of concrete of the column, it will be net volume, and when we have to calculate the formwork quantity, it will be outer surface area. Accordingly, we will define the level of information need for other structural elements such as beam, slabs, and staircase as well. After defining the level of information need and modeling rules for structural elements, the same process will be followed for the architectural model elements like floors, walls, doors, windows, etc. The process will be similar. And if I talk about the alphanumerical information, like information content, here I have taken the example of floor layer. Basically, the floor contains two main layers: finishing layer and the core layer. And the information content for those two layers will be QTO covering based quantities for finishing layer and QTO slab based quantities for the core layer. And accordingly, there IFC suggested QTO property will be net area. And after defining the level of information need and modeling rules, we will create the 3D model on the any authoring software, and then we will export it into IFC file, which will contain all the required information for to perform the Q2 and cost estimation. After exporting the IFC model, now the next task will be developing the cost database. The cost database will be developed using CPA OpenGen quantities application with the help of the selected WBS which we have used in our case in our study. So how this code database will be developed? The code database will be developed in three ways. Like first, we have to establish and integrate the work section for the project, and then with the different work section, we have to specify the each element present in the model. And then those elements will be like the cost of those elements will be defined according to the material, labor, and equipment required to generate a per unit quantity of that particular element. So on the basis of that, we will develop the cost database of the model. And then next task will be after defining the cost database, and we are having the IFC file. the next step will be to generate the general measurement rules. How those rules will be generated, and how 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 they will help to generate the final view of the project. Like, to generate the general measurement rules, first what we need to do is we need to list down all the elements present in the model and their IFC suggested QTO property against them. Like, if I'll talk about I have to calculate the beam formwork quantity. So what will be the IFC suggested QTO property? It will be outer surface area multiplied by 0.75. Why it will be multiplied by 0.75? Because we have to calculate the 3 out of the 4 surfaces. So after listing down all the elements and their specific general measurement rules, then we will go to the CPA OpenVim quantities application, and we will list down all the elements in the measurement rules section, and we will integrate those elements with the help of cost data and with the help of IFC properties. After linking the IFC properties with the cost data, the measurement rule will automatically extract all the quantities present in the model and generate the BOQ of the project. So it was the overall methodology. Now we will talk about the case application part. We did the 2 case studies in our work, first for structural model and another for architectural model. In structural model, we did the comparative analysis between the IFC model generated by CPGAT software, and we have created a replica model of that CPGAT model on the by using Revit authoring software. And the replica model was generated following the established modeling rules and the level of information needed. After establishing the replica model, after having the CPGAT model, we have evaluated both the IFC files, and after evaluating, we did the comparative analysis in different scenarios. Like, first for comparison of manual versus CPGAT quantities, and then we did the next comparison between the quantities of the CPGAT model generated by itself versus its quantities extracted using OpenVim quantities application. And third comparison, we did the quantities comparison of CPGAT and Revit model extracted using OpenVim quantities application. And in case of architectural model, we did it. We generated we have a CP architectural model IFC file, and then we have evaluated it. After that, we have generated the model using Revit authoring software, following the established modeling rules and level of information need. And then finally, we did the integrated discussion between the Revit and CP architectural model. So now, in the next, I will talk about only the quantity comparison of CPCAD and Revit model. The quantities was extracted using OpenVim quantities application. So before extracting the quantities, first what we did is, here we can see in the figure number 13 and 14. Figure number 13 stated the IFC received by CPCAD model, and the figure 14 stated the replica model which we have generated using Revit and following the established modeling rule. And first we did the evaluation of CPCAD IFC model, where we have found that the length, width, and height parameters was missing from its quantity sense, and the beam was passing through the pad footings. So this issue was rectified using the Blender BIM software, and we have added the missing parameters in that CPCAD IFC file, so that we can do the apple-to-apple comparison between both the IFC files. The next issue we have found in the CPCAD IFC file, that the staircase was modeled as an IFC stair, while its quantity set was showing as IFC stair flight. But according to IFC schema, if we are going to establish the model from the quantitative point of view, then staircase should be modeled as IFC, should be modeled in 2 parts. The stair flight should be modeled as IFC stair flight, and the landing should be modeled as IFC slab. And their quantity properties should be QTO IFC QTO flight based quantities, and for the landing part it should be QTO slab based quantity. After correcting the received IFC from the CPCAD, and after developing the replica model, we did the comparative analysis of the quantities for both the models, where we have found the variation between the concrete and formwork quantities of column and beams for both the models. And we have evaluated what was the reason. Like if I talk about the Rabbit model IFC quantities extracted using OpenBeam application. So concrete and formwork quantity was increasing in case of column, and the concrete and formwork quantities was decreasing in case of beam. Why they were increasing and decreasing? Because the both the models, like the model generated by Revit and the model generated by CPK, they followed different modeling rules. Like in our case, in our study, we use the CSRMC guidelines, which state that the column should go from the slab top to next level slab top, and CPK uses its own modeling rules. So that's why that variation was coming. And then we have evaluated how much percentage of variation was coming in the overall BO2. So we have found that the concrete quantity was decreased by 1.2% and the formwork quantity was decreased by 0.5% in case of replica model comparative to CPK model. So it was a very minor variation. So we can opt out these quantities from the final BO2. Then next comparison we did between the CP architecture model versus the replica model generated by Revit following the established modeling rules. So in the received IFC file generated by CP architecture, we have found that the CP architecture model contains only the core layers of the walls, slabs, and roof, etc. While the replica model which we have generated considering the established modeling rules. Like for example, if we have to establish a wall in a architecture model, so the wall should contain three layers. One is the core layer, and another is the interior finishing layer, and another is the exterior finishing layer. So accordingly, the whole model should be developed. So after developing the replica model, following the level of information need and modeling rules, we did an integrated discussion between the CP architecture and Revit model, where we have found that like here you can see I have highlighted the not applicable part in yellow in the comparison part, in the comparison list. And apart from these not applicable part, other element quantities were found to be similar in both the models. Why these not applicable part is here? Because CP architecture model doesn't contain those elements in the model. So finally, after discussing the quantities, it can be stated that for generating a general measurement rule, it is mandatory the element should be present within the model. So that was the final outcome. And if I talk about the conclusion and this future scope, this delineation highlights the importance of WBS in future and cost estimation. It also describes the importance of required level of information need and establishment of modeling rules. The general measurement rules were also established for the elements present in the model to estimate their quantities and cost estimate. This study also analyzed discrepancies in quantities between CPK and Revit models using OpenBeam quantities application. And it also discusses the gaps in architecture model by CP architecture and Revit. And the future scope, what could be the future scope? The other disciplines like MEP and the other structural types like the bridges, roads, and tunnel that can also be explored. And the automation of specific measurement rule can also be explored using open quantity application. Thank you.